Hello once again. Today we're going to talk a little bit about the secret sauce to self-hosting. So, what services do you want to host? You have to have an idea of that before you get started. Little advanced planning sure doesn't hurt. How many services do you want to host? Host on what exactly? Do you have a dedicated server? Do you have a network attached storage device, such as a NAS, Synology, QNAP, or are you running Proxmox? Or would you like to? And then what is your audience? What are the consumers of your self-hosted services? How many users do you have, and what kind of bandwidth do you have on your internet connection to host these services? What kind of storage, backup capability, and power do you need? And what is the cost of the infrastructure and time in order to do this? And then finally, what kind of effort will the support for this self-hosted infrastructure be? So first of all, what services do you want to host? Almost all hosted services are web-based and require transparent access to ports 80 and 443, and perhaps a few other ports depending upon the service that you've selected to host. Ports 80 and 443 and perhaps others must be opened on your router via a port forwarding command in order to be accessible from the public internet. Consider replacing a router that only provides DMZ capability instead of port forwarding. Some of the older and more basic routers allow you to take one particular system on your network and place it in a DMZ, which means it opens everything on that particular server to the internet, and then that device kind of straddles between your network and the public internet. It's not a very secure way to do things, and instead I would opt for a newer router that at least has port forwarding capability. The most common applications to host are a web server, which is usually based on WordPress. The majority of web servers today are hosted on WordPress open source. A discussion board such as PHP Bulletin Board or Discourse, and a chat server such as Rocket Chat or Zulip, and even perhaps a access portal like Apache Guacamole or a password manager like Bitwarden. I have an earlier video where I do discuss the Apache Guacamole quite a bit and how it's helpful in a self-hosted environment. And do you want to provide these services both internally to your home or also externally to the public internet? Really, we're going to focus on providing these externally to the public internet because running an application inside of your network is pretty straightforward. So how many services do you want to host and how? So this is kind of the secret sauce. If you host exactly one service, you can open ports 80 and 443 and create port forwards on your router to that one machine that's hosting that one service. So that's the simple case. If any of your services will be offered externally, you must buy a domain name for as little as $12 a year. And that pretty much goes even for one service if you want to offer it up. And there's some practical reasons to that we're going to look at in a minute. You're going to be defining a dynamic DNS record, a dynamic DNS record that points to your domain name at your service provider, or not your internet service provider, but your domain service provider. And on your local network, you're going to run a dynamic DNS client that keeps your WAN address in sync with your domain name. So, right, your internet service provider gives you exactly one wide area network address for your router, and that can change. That's why they call it a dynamic address. And so you have to have something that keeps your domain name in sync with that possibly changing address. And you want to make each service that you want to define a CNAME record that points to your domain name. A CNAME is an alias record. And so it'll look like they're all pointing to the same address. And that's true because they're all going to point to your WAN address on your system. But we'll get a little further here and you'll see why that works. If you host more than one service, and that's really the case we're talking about here, you should install a reverse proxy manager such as Nginx Reverse Proxy Manager and open ports 80 and 443 to point to it. So Nginx Reverse Proxy Manager acts as a gateway portal to all of your subdomain name services that point to your server instances. NPM manages Let's Encrypt, self-signed SSL certificates, and directing all internet requests to your domain named services. So what does this look like? This is a picture of the secret sauce. This is kind of a theoretical home network design, if you will. This is at the top, we have here our domain name service provider. You know, somebody like Cloudflare or Google or whoever you sign up with your domain name from. And on that, we would have a DDNS record. So for example, on my domain name is Scotti-BYTE.com, and I have a dynamic DNS record defined up at my domain name service provider, which happens to be Google, for Scotti-BYTE.com. And then I have 3 services I've given as examples here, which actually are legitimate services. One is a CNAME record for www.Scotti-BYTE.com, which is my web server. Another for discussion.Scotti-BYTE.com, which is my discourse server. And finally, one for chat.Scotti-BYTE.com, which is my Rocket Chat server. So then this line here represents the public internet. Your internet service provider is going to grant you a dynamic WAN address. So your modem is going to get, your whatever it is, your cable modem is going to get a dynamic DNS address that can change from your internet service provider. Let's say that WAN address is something like 73.206.54.10, just a number out of the air. That thing can change. And it's going to provide that to your router. And that's how the router knows how to communicate out onto the internet. And then also that's how things on the internet can get back to your router. So then sometimes a router will provide a DDNS, a dynamic DNS client, to update that dynamic DNS record when it changes. In other words, to pass the address it's gotten back up here to this domain name service provider so that the record always aligns to your address. And if not, then you have to run that dynamic DNS client on another machine inside your network, which is not difficult. It's pretty common. And then on the other side of your router, what we call the private side of the router is where you have your private address range. And so that's what on IPv4, which is what this is what we refer to as a network address translation network. A lot of people refer to this router as a firewall because of that. And it's called a firewall because primarily things on the internet cannot initiate contact with things inside the firewall or inside the private network unless there are rules set up to do that. Anyway, as an example, there are really 3 private address ranges that are widely published. One is you can have a local network that starts with 10.0.0.0 and can be anything in the 10 network, anything in the 172.16 network, up to 172.16.31, I guess I should have mentioned. And then anything in the 192.168 network at all. And the most common, if you go out and you get a router and you buy it and you go to configure it, almost always they'll define a private address range of 192.168.1. something. So I gave that as the example here and said, so my gateway address for my router is 192.168.1.1. Well, the reason we say that is because that's how anything on my local area network knows how to get to the internet. It first has to look at its router, its gateway address, and that finds the router. And then the router has the WAN address to get out to the internet. And then likewise, when things come back, if I go to a website on a node of my network, it basically encapsulates my local private address into the communication. And then that's encapsulated in a packet that says, well, this thing originated from the WAN address. And then whatever website, Amazon.com, comes back and says, well, okay, here's your return information. I'm going to send it back to this WAN address. And then when it hits the router's going to say, oh, okay, fine, where's this supposed to go to? And it goes to a particular address that initiated the contact, and so some local node in your network. So that's how it generally takes place. But for our purposes, we're really going to consider this to be a little different. We're going to perform what we call reverse proxy. And reverse proxy is where we have all these CNAME records. Now, if you look at creating this dynamic record for Scotti-BYTE.com, in my case, or your domain, in your case, you're going to find that that's one particular dotted address. It's going to be the one down here, as we mentioned. But then all of these CNAME records, which are called alias records, are all going to point to the exact same address, even though they're different names. But when somebody out on the internet requests connection to www.scotti-byte.com or discussion.scotti-byte.com or chat.scotti-byte.com, what ends up happening is that ports 80 and 443, we've set up with a port forward to talk to the machine that is running a reverse proxy. In this particular case, Nginx Reverse Proxy Manager. And that Nginx Reverse Proxy Manager is a portal to the named subdomains. These things, my domain is Scotti-BYTE.com, so a subdomain is www, another subdomain is discussion, another subdomain is chat. So what's happening here is that it will say, oh, okay, you've requested www.Scotti-BYTE.com. Well, basically, this Nginx Reverse Proxy is a lookup table, and it goes, well, if you want Scotti-BYTE.com, I'm going to send you to my private address, 192.168.1.20. It hits this machine right here because that's its address. That's the web server, and it communicates back to the person on the internet that requested that information. Likewise, the same thing, if it sees the incoming request for discussion.Scotti-BYTE.com, in this case, it might go for address 30, which might be this other node on your local network. And if they come to the rocket chat at chat.Scotti-BYTE.com, it's going to go to this .40 address and go to that server. And you can have lots of others. On my network, I have literally dozens of services that are accessible. So that's how the reverse proxy is set up, and that's kind of the secret sauce in doing all of this. So if you are watching videos and you're watching about self-hosting and you say, wow, I really would like to have a web server, and you watch somebody's video on how to install a web server or a discourse server, you go off and do that. But that doing the installation of that particular product may involve a lot of steps. However, all those steps rely on a larger level of an architecture that looks like what I call my secret sauce here. So what exactly do we host on? It's very common to self-host on cloud service providers such as DigitalOcean, Linode, AWS, and others. Oftentimes, cloud hosting is easier because cloud providers have built-in templates. Build me a Rocket Chat server. They actually have templates like that. And you also don't have to worry about router port forwards or reverse proxy. You wouldn't have to worry about Nginx Reverse Proxy Manager because the cloud provider is going to provide you an address that's already on the internet. And then the downside, unfortunately, is that cloud providers have recurring costs, which are generally anywhere between $5 to $50+ per month for the servers that they essentially rent you to run your application. So I consider real self-hosting to mean you're placing the service actually locally on your own network. And hence that's why I use the Nginx Reverse Proxy Manager and the dynamic DNS address for my domain name. I cover infrastructure in general, which is just touched upon here at depth in my self-hosting infrastructure tutorial on my YouTube channel here. And you need a machine that will be powered on 24/7 and can be dedicated to the job of self-hosting. I mean, if you power your machine down, your services kind of magically go away. So presumably if you're self-hosting, you want those services to always be accessible on the internet. Self-hosting is often on dedicated machines running something like Proxmox, which I've talked about to some degree, or on a larger network attached storage device from companies like QNAP or Synology. And those companies provide applications on their network attached storage that provide the ability to create virtual machines, Docker instances, and LXC, LXD container support. Also on my channel, I've had a pretty good tutorial on replacing virtual machines with LXC, LXD containers. If you haven't seen it, you should catch up on that. And you can host 2 or 3 small services on something as simple as a Raspberry Pi 4. So that's also pretty notable. You can do containers on a Pi 4, so on. There's a lot of videos out there that are dedicated to doing that sort of thing. But basically, whatever I've said here for an Intel-based machine also goes for something like a single board ARM-based Pi processor as well. It's just that you scale down significantly of what you're doing because the power and storage. So, who's my audience? What kind of bandwidth do I have? And how many users? So who are the consumers of your services? You have to understand what that is. And that's largely determined by what kinds of services you're going to be offering, right? And then how often will they access them? Are they going to be in once a day, twice a day, constantly, at odd hours of the night? I mean, you do serve a global audience here, so if you have users coming in from different countries, that's going to be critically important that these services be accessible. So the biggest roadblock, the absolute biggest roadblock to self-hosting from home is upload speed. Internet service providers always advertise their network in terms of saying, wow, we have gigabit speeds. And what they're saying is they have gigabit download speeds, but they have 30 megabit upload speeds. So when you self-host, just like kind of when you do video conferencing at home, your ability to transmit is important. So anybody connecting to your service from somewhere on the internet, they're going to be using your upload speed to get information from where you are back to them. And that's probably the biggest thing. As time moves on and we have more and more fiber services out there that have symmetric service, that'll probably lessen that concern. Symmetric services are when the upload and download speed match each other. But typical internet service providers offer asymmetric service. So how many users will be connected at once? Well, that kind of plays into the bandwidth. You have to be concerned about that sort of thing. All right, what about storage, backup, and power? Well, storage requirements in self-hosting are normally not really huge, so to speak, if all you have is a server providing chat or something along that lines. Unless you're serving a lot of content, something like Plex Media Server or Jellyfin, which is another media server, or a particular music server, where you might have tens of thousands of pictures or thousands of television shows or thousands of movies or thousands of audio tracks. All those sorts of things take up space. So if you have something that takes up space, of course you're going to need space. Large bulk storage should be highly available. So when you start scaling to these huge amounts, consider RAID 5 or RAID 6 arrays where they have a degree of fault tolerance. They can stand having a drive fail and not losing all your data. Or in the case of RAID 6, you can stand to have two drives fail and still not lose all of your data. You want to have your data highly available and also somewhat protected. Smaller hosted core storage for servers. If you have a small server that doesn't use a lot of space, you should consider just to host that server on NVMe or SATA SSDs for speed. And at the same time, again, in terms of fault tolerance, consider having a pair of SATAs or a pair of NVMEs, and consider doing RAID 1, which is mirroring. That way, if one of the devices fails, the other device is still there and you have an opportunity to replace it without having to rebuild everything. So the best backup solutions are actually exact replication copies. There's a couple of protocols out there that are really worth looking at. One is real-time remote replication, otherwise known as RTRR, and then also rsync, because they give you the opportunity to sync your data to another location in the event of some kind of a failure or corruption. And backup power. Backup power is very important. Uninterruptible power supplies, UPSs. They're highly recommended to protect hosted systems against brief power outages and glitches. I have a standing joke here in Houston, Texas, where I'm located, that Houston's power grid is serviced by Houston Spark and Flash, because we always have these momentary outages where you lose power for 5 seconds, 10 seconds, a minute, 2 minutes, and it comes back on. So having a UPS where you can ride through those kinds of power outages and glitches is really valuable in terms of not interrupting your services, but also really in protecting your expensive computer equipment. All right, what's the cost of infrastructure and time? Well, it takes time to plan a good self-hosting environment. You have to figure out exactly, what am I going to do? How much of it am I going to do? Can you dedicate an existing laptop or an existing old desktop machine? Or are you planning to buy a new computer or even a NAS to act as your server? And you can answer that question by understanding how many services you want to offer and how widely you want to be able to scale them. Will you have a dedicated IP address space, otherwise known as a VLAN? I've talked about VLANs a little in one of my other videos, for all your self-hosted services, or are you fine with offering them from your main LAN? So just like I tend to put my IoT on a separate VLAN on my network, I also tend to take most of my hosted services and provide them on a separate VLAN. And in order to have VLAN support, you need to invest in a level 2, level 3 router and L2, L3 switch in order to have a managed network so that you can support and manage VLANs. Most people have a retail router and they run an unmanaged network. So this is just an option to bolster the performance of your network and also bolster your security to some degree. So what about support? So installation of services. If I build a Rocket Chat server, hey, it's not the end of the support effort. You may be helping your users. They may have problems and they may ask you for help. And you'll need to have an admin email. Most of these products have some kind of admin email so they can send back information to the users or even have them register on these sites. And lately, you haven't been able to take, less and less so, I should say, you're able to go off and use, say, a Gmail account to do SMTP mail sends from these services. And it's because providers like Gmail are starting to limit that or actually break it on purpose, if you will. So you need to either have your own mail server where it does SMTP, which is no simple task, or you need to go out and use one of these services like SendGrid or Mailgun, which are designed to send out these sorts of administrative emails. I personally use SendGrid and it works really well. And then you have to be watching for security patches and upgrading your services. It seems like at least once a week I have some service that has a newer version or a security patch that I need to apply to it. And then finally, backing up your service databases. Well, if something happens to a server and it goes down that's offering, a forum or something, you want to make sure and have backup copies of the data that you have in that particular forum, or you're going to be starting from scratch. So, summary. Advanced planning for which services you want to host is important. We got that. I reiterated it a couple of times, and I can't emphasize enough how that is a big issue. You need to know what device you're actually going to be hosting on. You need to have an understanding of how much storage you need, what kinds of backup or data protection you're going to use, and whether or not you have a reasonable uninterruptible power system, a UPS, or at least understand that you can suffer outages and potentially equipment damage without such protection. And then be prepared to spend some time and money and expect your self-hosted environment to grow. Remember, it's not just a self-hosted environment, it's an addiction. Anyway, that's it for today. I appreciate your getting to this point in the video, and please subscribe and like if you like what you see.